You have to integrate the work done having the work done expression. Then you will have to consider isothermal conditions, and finally you will have to arrive at work done during isothermal condition. Okay, write the magnitude of K cap, and the magnitude of K cap is nothing but just K. Okay, orbital velocity as well as the time taken by using orbital velocity formula and time formula. Hello everyone, I'm Vrinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to the session in which we are discussing about the model question paper which was given by Department of Pre-University Education, that is the board model question paper of 21-22 year is being discussed over here in this session. So in today's class, let us discuss in detail of model question paper as well as the answers for particular questions. Here we have got the model question paper from Department of Pre-University Education, and it is all about the first PUC model question paper what we are discussing. So here basic instructions are the time for you to write the examination is given as 3 hours 15 minutes, wherein your first 15 minutes will be for you to check your question paper, rest of the 3 hours will be your writing session, wherein your maximum marks is all about 70 marks for which you will be writing the theory, and you will have the practicals for 30 marks. So you have got 50 questions in this question paper. So the basic instructions are all parts are compulsory. We have got 4 parts, part A, part B, part C and part D. So all these 4 parts are compulsory for you to attend, and answer without relevant diagram, figure or the circuit wherever necessary will not carry any marks. Remember that. So you will have to give necessary diagrams for certain answers. Third, it is direct answers to the numerical problems without writing the formula or the detailed solution also will not carry any marks. So numericals, which comes under part D and 6th Roman number, you will have to write the set of given terms and the formula to be used and the steps in order to solve the problems, that is in numericals, and finally you have to end it up with the answer as well as the SI unit. Only then you will be having the marks for numerical problems. So that is all about the basic instructions. Now let us get into the question paper, that is part A. In part A, we have got 15 questions. They have given you this time, it is a choice. Like in previous years, you have to write all the questions, but here in this case, you have got this year 15 questions, out of which you will have to select any 10 questions. The choice is up to you. It is any 10 questions and each question carries 1 mark. So totally from part A, you have got 10 marks. So here you have got answer any 10 of the following questions from part A and 15 questions, out of which the 10 questions will be answered by you. That's all about your part A. Now let us come to part B. So in part B, we have any 5 of the following questions, but what we have 10 questions with us. Out of those 10 questions, you have to opt for any 5 questions and each question carries 2 marks. So 2 mark questions, you have got 10 questions, you have to pick up any 5 and you will have to write. So 5 questions, each carrying 2 marks, again 10 marks will be there for you. So next let us go to part C. We are done with part A and part B. Now we are getting into part C. So what exactly is there in part C? Part C also, it is like you have to opt for any 5 of the following questions out of 10 set of questions. So each question carries 3 marks. So you have any 5 questions and into 3, that is 3 marks. Each question carries 3 marks. So it is 5 into 3, 15 marks is there in your pockets. That is from part C. You have to opt any 5 of the following questions out of 10 questions. So that's all about your part C. Answer any 5 of the following questions. So now we are done with our part A, part B and part C. Now let us get into part D. Here part D consists of 3 subdivisions, that is long answer is of 2 Roman numbers and the last Roman number is all about your numericals. So long answers, it's like you have got 4 set of questions. You will have to pick any 2 of the questions and you will have to write it. So 2 questions, each question carrying 5 marks. So you will have 10 marks from each Roman number. So you have 4 questions from this set. So you have to opt for any 2 and each carrying 5 marks and total of 10 marks for 4th Roman number. For 5th Roman number, again answer any 2 of the following questions. Again you have 4 questions out of which you have to write only 2. That can be any 2 of your own choice. Okay. And each consists of 5 marks. Again it will be 10 marks. So now here there is a twist, that is 4th Roman number and 5th Roman number is like the 4th Roman number is from your first textbook, that is part 1 of the physics NCERT textbook, whereas your 5th Roman number is from part 2 of your physics NCERT textbook. So here it is first textbook. From here, that is the 5th Roman number is all about from your second textbook. So first and second. So here your 5th Roman number is over. After this, let us move to the last subdivision of part D itself, that is numericals. So in numericals, it's like you have got 7 set of questions. Here we have 3 and 4, 5, 6, 7 from 7 different chapters. Okay, so we have this numericals from 7 different chapters and those chapters are noted down, please. It will be motion in a straight line, law of motion, gravitation, work energy power, system of particles and rotational motion, thermal properties of matter, and lastly it is waves. So from these 7 chapters you have 1 numericals. This will be from straight line, motion in a straight line, laws of motion, energy and power, and that is from system of particles and rotational motion. 48th one will be from gravitation, 49th is from thermal properties of matter, and 50th one is from waves chapter. So this is how you learn from only these 7 chapters. If you just study the numericals, it's sufficient. And out of these 7, it is like you will have to opt for any 3 of the numericals. So each numericals carry 5 marks. And the short technique is like there are 7 chapters out of which you have to opt for any 3 chapters numericals. So you can just study 3 chapters numericals thoroughly so that 5 marks will be in your pockets for all 3 chapters. That is all 3 numericals. So 15 marks will be getting from this numericals part. Okay. So that is all about your question paper pattern. We have part A, part B, part C and part D. Part A any 10 out of 15 and part B, it is any 5 out of 10. Part C, write any 5 out of 10. Part D, you have 3 sub-Roman numbers out of which you will be having from first, that is 4th Roman number, any 2 out of 4. 5th Roman number, any 2 long answer type questions out of 4. And 6th Roman number, any 3 numerical problems out of 7. So you have enormous amount of options. When that is the case, I wish you all the best for your exams. Study well and have the logic of the question paper pattern and write the exam well. Okay. Now I would like to solve few of the answers for the following question paper. So 1 marker question and 2 marker question, key answer will be taught to you here, and 3 marker question, 5 marker question as well as the numericals will have the hint for which you will have to work it out. So next we have, let us get into the question paper, that is from part A of the model question paper. So what is that? We have answer any 10 of the following questions, but here I'll be solving for all 15 questions. Okay, so here we have first one, name the domain of physics which includes phenomena at the laboratory and astronomical scale. As you can see on the slide, the answer is macroscopic scales, and that is the domain. Okay, next is, which is the strongest fundamental force in nature? It will be strong nuclear force. Okay, and the third question is like, define displacement of a particle. So what is displacement? As you all know, it is the shortest distance traveled by the particle from initial position to the final position. So that is all about your displacement. Next we have, write the magnitude of K cap, and the magnitude of K cap is nothing but just K. Okay, we have fifth question, for what angle of projection the range of a projectile is maximum, and this is from the chapter motion in a plane. Okay, so we will have to check the range of projectile is maximum for what angle. So angle is represented by theta, and what is theta? It should be 45 degree. It is half of 90 degree. So we have, this is 0, this is 90 degree. For this angle, that is theta, is equal to 45 degree. The range of projectile is said to be maximum. Okay, and next we have, state Aristotelian law of motion, that is external force is necessary for an object to have a motion. So it is external force is required to keep a body in motion is the answer for this question. And the next question is like, we will have to mention the expression for center of mass of a system of two particles lying in a straight line. See, since these are one word answer, instead of writing the answers in sentence, you can just give a word for it, that is the necessary answer for it, and that is sufficient. It's not necessary that you have to give complete sentence for each and every answer, because this is just a core subject. Okay, for languages it will be like you will have to give a sentence, wherein this subject doesn't need a sentence, it is just an answer what you will have to give. Okay, so mention the expression. They have asked only to mention the expression. Do that. Okay, mention the expression of what? Center of mass of a system of particles which is lying in a straight line. So just mention it and leave it as it is, wherein you will have to write, to be the safer side, you will have to write what is meant by R, what is meant by M. So it will be radius, it will be mass, like that you will have to define the terms. In this you will have to explain each terms. Okay, so now let us move to 8th question. So it's like, in a given materials, steel, brass and copper, there are 3 materials, which is more elastic? So this comes under mechanical properties of solid, where we study the elasticity behavior of a solid. So under that we have got, out of steel, brass and copper, the steel is said to be more elastic, okay, than brass and copper. If they give you just brass and copper, which is more elastic, it will be brass, and the least elasticity is produced by a material, that is copper. Clear? So steel is more elastic than brass and copper, and if it is brass and copper, brass will be more elastic than copper, and the least out of these 3 will be copper. Okay, so now let us move to the next question. What is a Magnus effect? Okay, and this comes in mechanical properties of liquids. Okay, so what do we study here? The Magnus effect is an effect in which the spinning of the ball or a cylinder curves away from its principal path. Okay, so that is all about your Magnus effect, which is here on the slide. And the next question, we are going to give the meaning of sublimation. What is meant by? Give the meaning in the sense, what is meant by? You will have to define what is sublimation. So that is converting solid directly into gas without going into the liquid state. So that is all about the sublimation. Next it is SI unit of thermal conductivity. As in the slide you have watts per meter per Kelvin. So which can be written as W M inverse and K inverse. So you will have to write what is, if you are writing this, you will have to write what is M, what is K and what is W, or else you can just go with all these, that is watts per meter per Kelvin, and in a symbolic representation. Both the ways also you can just write, okay, which carries 1 mark. Next it will be, we will have to write statement of zeroth law of thermodynamics, and statement is nothing but what does it state. So within the inverted commas or only the definition you can just write, like if a body A is in thermal equilibrium with C and body B also in thermal equilibrium with C, then body A is equal to body B. That is, A is in thermal equilibrium with B. So that is all about your zeroth law of thermodynamics. Just the statement, it is sufficient. It's not necessary that you have to give the expression. Wherever they have asked you to give the expression, there and then itself. If not, if you just give the statement, that is enough. And next we have, on what factors does the mean free path of a gas molecule depend? So what are the factors? Any one factor, if you just write, it is sufficient because it carries 1 mark, okay? But here I have given 4 to 5 factors on what the mean free path depends. So you can just opt for any one of the factor for 1 mark. So it can be density, or else you can even write radius of the molecule, or else you can write number of molecules, or else it can be pressure or temperature. It's up to you, okay? After this we have, give an example for periodic motion. So any one example is fine because it is only for 1 mark. Either it can be motion of hands of the clock, the periodic representation. After certain time interval, the motion repeats, okay? And so that repeating of motion is said to be periodic motion. So any example, so any object which possesses such kind of a periodic motion is taken as example, like the motion of hands of a clock, simple pendulum, motion of a swing, and earth moving around the sun, okay? Or else you in short you can just give it as revolution, okay? And next we have, what are free oscillations? So this is from the chapter Oscillation, and it is told that the oscillation of a body or a system when its own natural frequency is present and there is no influence of any external forces on the object. So that is known as free oscillation. So here we have got answers for all 15 questions, and which comes under part A, and each carries 1 mark. So if they ask you to check out for the factors or any question which is having 5 to 6 points, you can opt for any one of the point from certain questions and you can write, because it consists only for 1 mark, okay? And next it will be the part B of the model question paper. And what does it say? You will have to answer any 5 of the following questions out of 10 set of questions. So we have 5 into 2, it is nothing but 10, okay? So now write the number of significant figures in 2 set of decimal equations. So what do we have? 2.386. So it is a non-zero digits. So since it is a non-zero digits, we can count all 4. That is 1, this is 1, 2, 3 and 4. So we have 4 significant figures in this set, okay? Now let us move to the second one. How many numbers we have? 1, 2, 3, 4, 5. We have 5 set of digits, correct? So, but we have written 3 significant figure. Why is that? Okay, the number which is before the decimal is not a significant. Okay, and the number, that is the number very next to the point, very next to the decimal point, if you have 0, that also is not considered as significant. So now we are left with 3 digits. So the number that is a 0, which is after the non-zero digits, can be considered as the significant figures, but the 0 just after the decimal point is not the significant figures. So this set of question is very easy for you to understand if you know the rules. So we have 3 significant figures which we are left out. So that is all about your 16th question. Now we have got distinguish between scalars and vectors. So that is a difference between scalars and vector what you're giving. This one, this is a scalar and this is a vector. You will have to make a table for this and draw a partition line and write what is this. That is a scalar as a heading, and here it has, here vectors as a heading. So when that is the case, you will have to pick up few points, 1 point, 2 point, 3 point. So since it consists of 2 marks, you can write any 2 points. Okay, any 2 points you can write. It can be like a sentence and an example, which makes one is sentence, that is the definition of scalar, and one is the example, or you can even write 2 sentences for the scalars without the example also, okay. But the thing is, whatever is present here, that is in case of scalar, the same thing has to be there in contrast to it. Here if you have any sentence, the same sentence should match up with the vectors as well, okay. So now it has got only magnitude and no direction you'll be writing. In the next one, first point itself, if you write an example, that is not valid, okay. So here it has to be only magnitude and no direction. The first point comes here, this will be the first point, and the first point in vectors will be, it has magnitude and direction. The second point, only one dimension, and this is applied to 1D, 2D, 3D, that is 1, 2, 3, all 3 dimensions, okay. So that is how you write the difference. This is all about the question, that is the difference between scalars and vectors. Now let us move to the other question, which tells that what is centripetal acceleration, and give the expression for the centripetal acceleration. So they have asked 2 things for 2 marks. What is centripetal acceleration? So you have to define what is centripetal acceleration, and they have asked you to give the expression for it. So you have defined centripetal acceleration for 1 mark and you're giving expression for the other mark. So here you will have to check, that is, here you will have to give the following terms. What is meant by M, what is V, what is R, and what is FC. This is how you will have to write the answer. So what is centripetal acceleration? Definition 1 mark, and the expression here also we will have 1 mark. You will have to explain the terms of the equation. So that is all about your 18th question. Now let us move, like, mention any 2 advantages of friction. Since it is for 2 marks, they have asked you to mention only 2 set of advantages, that is any one out of all 4 advantages. You can opt for any one and each carries 1 mark. Each of the points carries 1 mark, okay. So one is friction enables us to walk freely. Second point is objects can be piled up without slipping. When there is friction, there is no slipping which occurs. And third, it is brakes of vehicles work due to the friction. And lastly, it becomes possible to transfer one form of the energy to the other form. So all these are the advantages of friction. Now let us move to the next question, that is state and explain Hoax law. So they have asked you to state Hoax law and explain Hoax law, whereas statement consists of 1 mark, explanation consists of the other mark, okay. So it is 1 mark plus 1 mark. Here They have not asked you for the expression. So it's not necessary that you have to break your head for expression. They have asked you only to state and explain what is actually Hooke's law. Okay. So if you just give the formula also, it's well and good to be at the safer side. But here they have asked you to explain and the statement. Okay. So within the elastic limit, the stress is proportional to strain, and the same statement's explanation is given over here for 1 mark. Next, let us move to write the expression for capillary rise of the liquid, and we will have to explain the terms. So here we have the expression for capillary rise, and this comes under the chapter Mechanical Properties of Fluids, that is the liquids, which comes in your second textbook, that is part 2 of your NCERT textbook. Okay, so we have under capillary rise, we have this equation for the capillary rise of liquid, and we will have to explain the terms. So 1 mark to this expression and 1 mark to explaining the terms. This is how we divide the question, set of question. Okay, after which we will be having convert 100 degrees Celsius to Fahrenheit as well as Kelvin scale of the temperature. So this chapter, that is this question, is from the chapter that is thermal properties of matter, wherein there is a formula for you to convert for the Kelvin as well as Fahrenheit scale. So here these are the two formulas wherein you will be considering this is the temperature, whatever it's given over here, and the way of converting is K is equal to whatever temperature you have in degrees Celsius plus 273.15 is the formula, and for Fahrenheit we have 9 into K minus 273.15 plus 32 divided by, this will be the square bracket, and it is 5. So this is the formula to find out Fahrenheit, and this is the formula to find scale, and 1 mark, total of it is 2 mark from this question, that is question number 22. Now let us move to the next question, and what does next question tells? We have to mention degrees of freedom for monoatomic molecules and diatomic molecules. They just have asked you to mention the degrees of freedom and not to derive the complete thing. Okay, just you have to mention it. So for monoatomic molecule you have 3, for diatomic molecule you have 5. So these are the 2 points. So one first sub question consists of 1 mark, second sub question 1 mark, and totally it is a package of 2 marks. Okay, so this is all about this question, and now we are moving to the graph which represents variation of displacement and variation of velocity with respect to time for a particle. A particle is there which possess, that is which exhibits simple harmonic motion. So this is from the chapter Oscillations. Okay, so here there is a particle which exerts simple harmonic motion. We have to check a graph for the particle, that is displacement as a function of time, velocity as a function of time. So here displacement as a function of time in x-axis, the same thing velocity in y-axis, and time t in x-axis. So that is how you plot the graph. So this will be for first question, and this is for the second sub question. So overall it is like for 2 marks. One graph consists of 1 mark from this question. So you will have to mention x-axis, what is it? That is time. Y-axis, it's displacement. All these are the things what you have to write in your graphical representation. You will have to mention this t by 2, t3, t by 2. Those are the phases. Okay, so that one you will have to mention. Now let us move to the next question. What are nodes and antinodes? And this set of question is from chapter Waves. So antinodes are the points on a stationary wave which oscillate with maximum amplitude, and nodes are the points of zero amplitude. So in the form of a wave, we have this set to be antinodes, and this set is nodes. This set is said to be nodes. Okay, so we have antinodes and nodes. So antinodes are the one wherein you will have maximum amplitude, and nodes is the one where you have zero amplitude. So that is all about this answer. Okay, next is, it is part C, that is third Roman number. Here you will have to answer any 5 of the following question, and each question carries 3 marks. Okay, it's like only any 5 of the following questions, out of which each question carrying 3 marks. 5 into 3, it's total of 15. So what do we have here? We will have to write 2 applications and 1 limitation of dimensional analysis. 2 applications, 1 limitations. So each point carries 1 mark. Okay, so here we have applications. This is for 1 mark, this is 1 mark, and other one, out of these 2 you can opt any one, and it is for 1 mark. Okay, application is like to convert a physical quantity from one system of units to another, and second one is to check the correctness of given physical quantity. Those are the applications. And limitations, like it doesn't tell how to determine the value of constant of proportionality, and it cannot be used to determine the relation between more than 3 quantities. So maximum up till only 3 quantities we can identify, but more than 3 we can't determine using this dimension analysis. So that is all about your third Roman number, that is 3 marks question, first question. Next, let us move to define relative velocity. So first is, we have to define what is meant by relative velocity of an object with respect to another, and you will have to give the position time graph for 2 set of objects that is moving in a straight line when their relative velocities, one is 0 and non-zero. So this will be the set of graphical representation, and the answer for the what is meant by relative velocity is given here. So this consists of 1 mark. First graph is for 1 mark and second graph is for 1 mark. So we have 3 marks on total from this question. That is the 27th question. We will have to define what is relative velocity and check the relative velocities by drawing position time graph for 2 objects with respect to each other. One is for 0 as well as another one is for non-zero. Okay, non-zero relative velocity and 0 relative velocity. So that is all about this graphical representation. So now let us move to the next question. So what does it tell? We will have to obtain the expression for time of flight of a projectile. Okay, first of all you will have to draw the projectile diagram, which is given here in this slide. Okay, so by doing this diagram, you will have these set of points. One is like you will have to do the diagram, and then you have to give the introduction to the diagram, that is, consider an object which is getting projected through certain angle theta. In that way you will have to explain this diagram, at least 2 or 3 lines, and then you will have to derive for time of flight. That is the first set of equation, that is t is equal to 2u sine theta divided by g. Up till here you will have to derive the equation, and then we will have to explain what is meant by u, what is sine theta, what is g, and what is t. These are the explaining terms in formula. Okay, so that is all about your question number 28. Now let us move to the next question. Show that torque is equal to rate of change of angular momentum of a particle. So having this equation, you have to differentiate it and you will have to arrive at this form, that is dl by dt is equal to tau. Okay, after which you will have to explain the terms which is used in expression. So the whole part will consist of 3 marks. So first of all, you have to consider first set of equation and you have to differentiate that set of equation and arrive at the formula, wherein your 3 mark will get completed only when you explain the terms of the following formula which is given. Okay. So this is very important. So you will not have to forget this step, that is explaining terms of any set of the formulas, out of which the main thing goes from here to here, that is considering a formula and then you will have to differentiate it and arrive at the rate of change of angular momentum is equal to tau. So angular momentum expression and rate of change of angular momentum after differentiation, final answer you will have to give, and between you will have to differentiate things. So that is all about this question. Next, let us move to, we have to define 3 definitions for Young's modulus, bulk modulus and shear modulus, and those 3 definitions are given over here. That is the ratio of longitudinal stress to longitudinal strain, the ratio of tangential stress to the shearing strain, and the ratio of hydraulic stress to the volume strain is all about your Young's modulus, shear modulus as well as bulk modulus. So here each consists of 1 marks. So next question is like state Pascal's law. We will have to mention any 2 applications of the Pascal's law. Statement 1 mark, one application 1 mark, other application for 1 mark. So total of 3 marks. So here it states that an external pressure which is applied to any part of an enclosed mass of a fluid at rest is transmitted undiminished to every portion of the fluid and the walls of the containing vessel. So this is all about the definition of, that is a statement of Pascal's law. Its applications, there are 2 applications, that is hydraulic lift and hydraulic brake. It's not necessary that you have to explain these applications. It is just they've asked you to mention the application, so just the heading is sufficient of hydraulic lift as well as hydraulic brake and no need of explanations. Next is derive an expression for a work done in an isothermal process. So we have to derive some expression of work done when in isothermal condition. And what is isothermal condition? It is nothing but the temperature which is said to be constant in isothermal condition. So here we have to take ideal gas equation, PV is equal to RT. Having that ideal gas equation, we have to integrate to the work which is done. Okay. So after integrating for the work done, then you will have to consider the isothermal process condition, and finally we will have to arrive at this formula. So this will be the final derivation, that is final expression for this set of questions. First of all, consider ideal gas equation. So that is one part where you have to, these are the this is not the answers for these questions. This is just the hint what and all you are supposed to do. Consider an ideal gas equation. You will have to integrate the work done having the work done expression. Then you will have to consider isothermal conditions, and finally you will have to arrive at work done during isothermal condition. Okay. After which the next question will be like, we will have to state any 3 assumptions for kinetic theory of gases. So that can be the postulates what you opt for. Okay. So out of which I have considered these 3, which out of those many postulates and assumptions, you can consider any of the 3 points for you to write. Okay. So these are that all gases are made up of molecules that are constantly, these are just the assumption, okay, that are constantly and persistently moving in random direction. That will be the first point for 1 mark. Second point for other mark, that is 2 marks. All the collisions between molecules and even between molecules and the walls are considered to be elastic. And finally for 3rd marks, that is 3 marks, we have the separation between the molecules is much greater than the size of the molecules. These are the assumptions considered from those assumptions which is given in your textbook. So out of those many assumptions, you can consider any of the 3, whatever you feel easy. Okay. So here it is like you, for 3 marks, you will have to give at least of 3 points. Okay. After which we have the part 3, that is the 4th Roman number. So we are done with our part A, part B and part C, 1 marker question, 2 marker questions and 3 marker questions. Now we are stepping into all about the 5 marker question. In each and every Roman number we have 5, like we are dealing with 4th Roman number, 5th Roman number and 6th Roman number. So all 3 Roman numbers are having 5 marks. It is like in first main you will have to, that is the 4th main, you will have to opt for 2 questions out of 4, 5th main also 2 questions out of 4 and 6th main is 3 questions out of 7. Okay. So here we have to derive the expression for magnitude and direction of the resultant of 2 concurrent vectors which makes an angle theta between them. So here we have the expressions of magnitude and directions of the resultant of 2 concurrent vectors, that is we are considering 2 concurrent vectors, okay, which makes an angle theta between them. So there is an angle theta between them. So we are just studying about the parallelogram law of vector addition. So we have to give the diagram of parallelogram law of vectors. So one will be your diagram, and that is a neatly labeled diagram where exactly the angle comes, where which vector is this vector, each and everything you will have to draw it neatly. So refer for the textbook. However it is given in the textbook, same thing, you can just drop it in your paper. So neat diagram of a parallelogram has to be drawn and label the parts, and then it will be derive the expression for magnitude and direction. So there is a derivation of expression for parallelogram law, and that derivation you're supposed to neatly do, and finally you will have to explain the terms of the expression. So these are the set of conditions like how you have to write the paper. So for this, the diagram, the expressions and the explaining the terms, all these 3 set consist totally of 5 marks, okay, and the marks will be divided. For few marks will be for diagram, that is 1 or 2 marks, and finally for the steps whatever you write there, it will contain certain marks, and finally for the answer it is for 1 mark, and finally the explaining the terms of the expression also will carry marks. So this is how the distribution of marks goes on, okay. Next question will be state and prove the law of conservation of linear momentum using Newton's law of motion. So we will have to give the statement as it is given there. The total momentum of the system is always said to be conserved if no external force is acting on them, okay. So this is how it is. Next we will go to the proof. And what is that proof? Introduction of 2 objects. We have to consider 2 objects which is moving with certain velocity, which is having certain mass. So that is the way you introduce the set of apparatus which you are using here, that is considering here. It is like you'll be considering 2 set of balls. One is initial state, both are at the initial condition, that is body A and body B, and when body A moves with certain velocity, it hits body B. All those things are there, those are the general introductions, okay. So having those introduction, we will have to arrive at the equation m1u1 plus m2u2, which is equal to m1v1 is equal to m2v2. So that is how you arrive at this equation. After arriving at this equation, what is m, what is u, what is v, these are the things what you have to explain in this expression, explain the terms. The whole thing consists totally of 5 marks, okay. So now let us move to the next question. It is like, what is meant by inelastic collision, and obtain the expression for loss in kinetic energy in case of completely inelastic collisions in one dimension. So first of all, you will have to define for whatever question they have asked. What is the question? That is, what is meant by inelastic collision? That is a definition which has to be given, and the derivation whatever they have asked for, that is expression for loss in kinetic energy in case of completely inelastic collisions in one dimension. So this will be the what is meant by kinetic energy, okay. Inelastic collision, that is, it is a type of collision which takes place between 2 objects in which some energy is said to be lost. That means momentum is conserved but kinetic energy is not conserved, okay. That should be the main part of this inelastic collision statement. Then you have with a neat diagram, we will have to arrive at the equation and we have to explain the terms which is used. And what will be the formula? It is of this half m1 m2 divided by m into v1 minus v2 the whole square. So this will be the formula for it. You have to arrive at this equation and explain the following terms for this equation. What is meant by m? So you can just write like where m is so and so, capital M is this part, V is this part, V2 is this part. So these are like how you explain the terms for each and every conditions. So that's all about this question which carries 5 marks. Now let us move to the next question. Here it is like we have to define moment of inertia. We have to state and explain what? Two things, that is theorem of perpendicular axis and theorem of parallel axis. So these two are the set of equation where you will have to explain, okay. So it is like we have to just give the definition of moment of inertia and we have to state and explain two theorems, okay, with a diagram. So definition, sum of product of mass of every particle with square of its distance from the axis of rotation is its definition, which carries 1 mark, and rest of the marks like 2 marks goes for first, that is the theorem of perpendicular axis, and next 2 marks will go for theorem of parallel axis, which is totally of 5 marks, okay. So with respective diagrams, remember students, without the diagram don't go to explain the theorem. Relevant diagram is very much important, only then that specific question carries marks, that is full marks. You have read the instructions of the question paper itself, okay. So with the respective diagrams, explain the theorems and its respective terms of the formula used, okay. Here also these set of questions are from the second textbook of yours, and this is like each question carries 5 marks. We have to write any 2 questions, so we will be getting 10 marks. And how many options are there? There are 4 options. You will have to opt any 2, out of which 2 will be left as it is, okay. So here we have derive the expression for acceleration due to gravity at a point below the surface, that is the depth of the earth. So what is that equation which is there below the surface? It's like this will be the introductory part. Okay, let m be a mass of the earth and r be the radius of the earth, like that. You can give the introductory part only if the diagram is there. So you will have to draw the diagram. Okay, so diagram is very important. After drawing the diagram, you have to give this introduction, and after giving introduction, you just have to mention what is CS. You can just see in the set of diagrams, you can just see in a diagram what is C, what is S, what is C, and what is P, and all those stuff, as well as D. So this is the format you will have to consider. After this, you will have to use the relation between G and G formula, and then you have to finally arrive at the depth of the Earth's expression, and you have to explain the terms of those expressions. So that is all about your terms of the expressions. Like again, the same answer is continued over here. So this will be the final expression where you will be giving the depth. Okay, at the depth, what is the acceleration due to gravity, which is mentioned by D, and this will be the formula, and explain each and every terms here. Explain the terms. Okay, this overall consists of 5 marks. Okay, after this, you will have to explain what is Carnot cycle. The next question is explain Carnot cycle with PV diagram. So you have got a PV diagram. Okay, PV diagram. In that PV diagram, you will have to use the graphical representation, that is this. I hope you all are aware of this kind of diagram, A, B, C and D. So the arrow mark states this. Here 2 set of compressions undergoes compression, that is isothermal compression, adiabatic compression, expansion and adiabatic expansion. So these are the conditions of this PV diagram. So it's like you people have to explain all 4 conditions. They have asked you just to explain, and explanation of Carnot cycle is so very different from completing the, that is you're getting the efficiency of Carnot cycle. Efficiency means you will have to sum up all the Carnot cycle, that is W1, W2, W3, W4. These are the things like you have to sum it up and you have to equate it. But this equation is discarded here. They have asked only to explain. So only explanation is sufficient for this Carnot cycle with PV diagram. How exactly the Carnot engine works and why are we getting such kind of a graph. That's all is enough for you to explain. Okay, so here use the graphical representation and you will have to explain each of the steps, that is curve AB, curve BC, curve CD and DA. Like this you will have to explain each of the curves in this set, that is a Carnot cycle. Just explain like how you're getting curve, explain about isothermal and adiabatic compressions, isothermal and adiabatic expansions. Okay, so these are the things. Next question is like arrive at the expression. We have to arrive at the expression for the time period of oscillation. So this is from the chapter Oscillations. So here we have to arrive at certain expressions. So how we do that? First of all, we will have to draw the diagram and we have to neatly label what is theta, how the force is exerted over there and all. Okay, after which the introduction, like consider a bob with a string which is tied and it is made to move. All those things are the introductory part of the diagram. Okay. And then you will have to consider the restoring force F is equal to minus mg sine theta. Having that, you will have to arrive at acceleration A is equal to F by m and you have to solve in this manner. And after this concept, you will have to get T is equal to 2 pi root of Lg. So these are the important steps where what exactly you have to do. But you have to fill the derivation, that is the left out part between these equations. This is not the complete set of answer. This is just the hint what I'm giving you, like how you're supposed to write the answer. So this will be your final equation, out of which you will have to, again I'm repeating, you will have to explain the following terms of this expression. Okay, clear? After this we will have to write Newton's formula for speed of sound in a gas. That is, write Newton's formula for speed of sound in gas medium and discuss the Laplace correction for it. They didn't ask you arrive at Newton's formula. So no need to arrive at Newton's formula, that is derivation for the first one. Just write the Newton's formula for speed of sound in gas medium. Just write the formula and then you will have to consider, you will have to give the Laplace correction to it. So just write this and give the Laplace correction to this set of equation. Write and give the for Laplace correction, you will have to derive the equation. So that is all about your 5 marks question. And finally, we are moving to the 6th Roman number, that is the Numericals chapter, Numericals Roman number, wherein you will be having 7 set of questions. You have to opt for any 3. So from any 7 chapters, as I told you at the beginning, you can study any 3 chapters numericals and you can come to exam. Okay. So it's like a car moving along a straight highway with a speed of 126 km per hour is brought to stop within a distance of 200 meters. So what are we supposed to calculate? Retardation of the car, that is the negative acceleration, by assuming it to be uniform, and we have to calculate the time taken, that is the T, by the car to stop. For that, use Newton's equation of motion, that is V square minus U square is equal to 2as. Write the given terms. Before all this, you have to write the given set of equations by reading the questions. Okay. Read the question carefully and write the givens, and finally write the formula and solve for this formula, wherein later you will be having to solve for V is equal to U plus AT, and finally you will end up with these 2 answers. So that is all about your 44th question. I want you people to work out these questions by using the following hint. Okay. And the next question is like, a circular racetrack of radius 300 meters is banked at an angle of 15 degrees. If the coefficient of friction between the wheels of the race car and the road is 0.2, find the optimum speed of the race car to avoid wear and tear on its tires. And second question, maximum permissible speed to avoid slipping. So it's like write the given terms. What are given with the help of questions. Next, write the formula, which formula to be used. Okay, and then finally use optimum speed of the car. In order to find optimum speed of the car, you have to use tan theta is equal to v square divided by r into g, and we have to find v is equal to 28 meter per second. And we have to find maximum permissible speed to avoid slipping. In order to find that, we will just refer for this equation and get the answer. Vm is equal to 38.19 meter per second. So that is all about your 45th question. We are left out with 5 more questions to complete this model question paper questions. Okay. And next is a body of mass 0.1 kg falling freely under gravity 10 seconds to reach the ground. Okay. And we have to calculate the kinetic energy and potential energy of the body when it has traveled for first 6 seconds, and they have already given that is 9.8 meter per second square. So this is a set of questions wherein it has got 5 marks, and this is from the chapter Work, Energy and Power. So here, first of all, by reading the questions, you will have to write given, then use the formula, then you will have to work it out as given here. Use V is equal to ut plus at and get the value for V. Find the kinetic energy of the body when the body has traveled for 6 seconds using kinetic energy's formula, that is half mv square. Then find the potential energy, and in order to find the potential energy, you will have to have the height, that is for mgh you should have the height. In order to have the height, you will have to subtract 2 of the distances, that is the main distance with the distance what it takes later. So S1 minus S2. So in order to have S, you will have to write, that is use the Newton's equation of motion. S is equal to ut plus half at square, that is A is considered to be g, and it should be considered, subtract 2 distances whatever we get from that S, and finally substitute for H in the potential energy formula. The formula is given there, that is mgh, and we will arrive at the answer. Potential energy is equal to 307.3 joules. So that is all about this question. And next we are moving on to 47th question. And what does it say? A meter stick is balanced on a knife edge at its center when 2 coins, each of mass 5 grams, are put on the top of the other. At the 12 centimeter mark, the stick is found to be balanced at 45 centimeters. Okay. So we'll have to calculate the mass of the meter stick. So in order to calculate, the complete sum has been done here. That is, we have to consider the weights, that is which is given over here, that according to the diagram, write the introductory part, write the given terms, and mass of the meter stick is equal to m dash mass of the coins. Each coin should be 5 grams. And then the diagram represents you each and everything about this question. And having that in equilibrium, we have to take moment of force about C dash. And what do we get? We get 10 grams and multiplied that 45 minus 12. These are all the set of equations how you have to go with. And finally, what are they asked you to find out? M. So keep the term which has to be identified at your left hand side and get the equation which has got the answer as 66 grams. So I hope you're clear like how to do it. Instead of explaining, I'm just giving you the hint of these things. So just go through these hints and then you yourself will have to work it out. Okay. Later, next is an artificial satellite is going around the earth close to its surface. What are we supposed to do? We have to find orbital velocity of the satellite and time taken by it to complete one round. We have to find orbital satellite, orbital velocity as well as the time taken by using orbital velocity formula and time formula. So it can be considered as orbital velocity is equal to root of gm divided by r equation. It can also be given as v is equal, this will be just the velocity to find out. So g r e square divided by r. So this is the orbital velocity formula, and in order to find out time t is equal to, we have 2 pi r divided by v. Whatever we get, we can substitute here and find out for the second sub question, that is time taken by a satellites to complete one round. So that is how you just equate this. So this will be from the chapter gravitation. Next, going on to the next question, a pan filled with hot food cools from 94 degrees Celsius. So when you read this, all those Celsius things, Kelvin, Fahrenheit and all, it is always from thermal properties of matter, okay? So a pan filled with hot food cools from now 94 degrees Celsius to 86 degrees Celsius in just 2 minutes. When the room temperature is at 20 degrees Celsius, how long it will take to cool from 71 to 69 degrees Celsius is a question. So in order to solve those things, we have Newton's law of cooling with approximation. So that equation for you to solve for this question. So in case 1, we have to find out two cases. In case 1, we have to find the value of this, and the value is given here. In case 2, you have to find the value of T average, and it is given here. And finally, find for the value of dt. So dt will be 2.8 minutes is required. That is change in temperature. In order to have change in temperature, how many minutes it requires? It requires 2.8 minutes. That is change in time. As there is change in time, there is change in temperature, okay? So D, capital T is said to be change in temperature, and dt is nothing but the change in time in this question. And finally, we are moving to the end of this question paper, that is the 50th question. So what does it say? For traveling harmonic waves, equation is given there, where x and y are in centimeters and t in seconds. So they have given the SI units for each and everything. Calculate the frequency and the speed of the wave. Also calculate the distance between two successive crests in the wave. So they have asked you to calculate 3 things. That is, calculate speed and frequency. Speed means it will be the wave velocity. Frequency is nothing but just f is equal to 1 by t, whatever you give. And then also we will have to calculate the distance between two successive crests and trough. So this is a complicated question a little. So here we have a wave. These are the 2 crests and these are the 2 troughs. So the distance between 2 crests is nothing but the wavelength, okay? So finally they have asked you to find out the wavelength. That's all. There is nothing for you to break your head. So first use the formula for frequency, find out frequency, use the formula for wave velocity, find the wave velocity, and finally use the formula for wavelength and find the wavelength. And remember students, whenever you write each and every equations, that is after writing equations, after solving for the equations, you'll get certain answers. After getting certain answers, I want you people to write the SI unit, because SI unit answers along with SI unit consists of 1 mark, okay? I don't want you to miss 1 mark in that case. So remember, in numericals, you will have to write given terms, you will have to write the formula, you have to substitute for the formula, solve it, write the answer with the SI unit, and there you will get complete of 5 marks. So from 6th Roman number, if you solve all 3, whatever you're opting, you'll be having 15 marks in your pockets, okay? So this is all about your model question paper discussion. So I hope you're clear with today's class of solving model question papers, which is released from the board. So I hope you're clear with today's class. So let us all meet in the next class with the next upcoming sessions. Until then, have a good day. Thank you.